So equilibrium constant Kc and Kp. First, I will discuss the doubts related to this exercise. The first one is question 4, part 3. So the first doubt from this one is question number 4 in parts. I will solve the full question 4 so that you will have an idea. The first one, the equation for equilibrium between the nitrogen and oxygen may be written in two ways. We can write nitrogen plus oxygen give 2 moles of nitrogen monoxide, or half mole of nitrogen plus half mole of oxygen give 1 mole of nitrogen monoxide. Standard enthalpy change for this reaction is shown there, which is about 180 kilojoules per mole. What is the standard enthalpy change for reaction as shown in the second equation? So when we compare the two equations, like here, we were getting 2 moles of a product, like 1 mole of nitrogen, 1 mole of oxygen give 2 moles of nitrogen monoxide. Here, half moles give a 1 mole, so means the enthalpy, if the number of moles are half or divided by 2, what will happen to enthalpy change for the second reaction? That will also be half of the first one. So if the first reaction it is 180, then half of 180 is 90, so B should be the right answer. The second part, equilibrium mole fraction of NO is increased by, like how we can shift the equilibrium towards right hand side. So this forward reaction is endothermic. For endothermic reaction, if we increase the temperature, the equilibrium will shift towards the right hand side. And what about the pressure? The pressure does not have any effect on mole fraction here. Why? Because we have equal moles of the reactant and product. We have 1 mole of a nitrogen, 1 mole of oxygen, so total 2 moles are there for reactant, and there are total 2 moles of a product. So number of moles of reactant products are same. That's why the pressure and number of moles of gas for the reactant product are same. That's why the equilibrium is not affected by changing the pressure. So, and the forward reaction is endothermic. So for endothermic reactions, the reactants have low energy and the product is having high energy. So when we increase the temperature, the equilibrium or the balance will shift towards the right hand side. The third one, which of the following expression is correct? Like how we can relate the equilibrium constant for the first reaction with the second reaction. So Kc or Kp is the product divided by reactant. So when I write the value for Kc or Kp for equilibrium constant for the first reaction, which is a product, the concentration of NO square divided by reactant nitrogen plus oxygen. This is the first reaction. If I write the equilibrium constant for the second one, that is the concentration of a product divided by concentration of reactant. And this is half is there. And this one is also oxygen raised to power half. So if I make the right hand side equal, I can, because here right hand side I have NO square divided by N2 and O2. So how I can make the right hand side equal? If I square this equation both sides, like I square this equation. So as a result, when I square, so this will become K2 square is equals to the concentration of NO square divided by concentration of N2 and concentration of oxygen. Because the square and half, like root and square, will cancel out. So means if the right hand sides are equal, the left hand side will also be equal when we compare. So I can say K1 is equals to K2 square. If K1 is equals to K2 square, so K1 is equals to K2 square, so it matches with option C. So C will be the right answer. So what we did, we write the K expression, the Kc for both the two equations, and then we make the number of the, like the concentration on the right hand side equal by square the second equation, and then we compare the two equations. So this gives an expression that K1 is equals to K2 square. Is it clear, this part? The next doubt from this exercise, that is question 15. So question 15, part B, the main doubt, but I will discuss both parts. So the decomposition of a hydrogen iodide at 500 Kelvin in equilibrium reaction. What is the effect of raising the pressure of the reaction mixture on the reaction rate, equilibrium yield, and the value for Kc? First thing, remember the value of the Kc or Kp is only affected by temperature. Like if we change the temperature, the value of the Kc or Kp will change. So means options which are with are no change should be the answer. Then as the forward reaction is endothermic, if the forward reaction is endothermic and uh, we are just changing the pressure, so we have to check the moles of the gas. So when you check the moles of the gas, here we have 1 mole of a gas, here half and half makes 1. So means the number of the moles in the reactant and the product side is same. So when we increase the pressure, it will not shift the equilibrium either towards the right or the left hand side. So the yield will not change. So there should be no change in the yield. And what happened to the rate? As we increase the pressure, the particles come closer. Often they collide with each other. As a result, the rate of the reaction will increase. That's why A will be the right answer. Now, this is a similar question for part B, that how we can combine the two equations, like about the enthalpy change. As you check for enthalpy change, the first one, it's a similar question like we did in the previous one. So here we were having 1 mole of hydrogen iodide, and the other one we have 2 moles of hydrogen iodide. So when we compare this, like delta H1, and this will be like for the second reaction, delta H2 will be twice of delta H1. Why twice? Like if this enthalpy change is delta H1, the enthalpy change for the second reaction, because the number of moles are doubled. Like here was 1 half half, but for this one it is 2 1 and 1. So the number of moles are double, the enthalpy change will also be double, so it will be twice of delta H1. Or we can say delta H2 is equals to 2 times delta H1, or delta H1, because if we need delta H1, so delta H2 divided by 2 will be equal to delta H1. Means delta H1 will be delta H2 divided by 2. So delta H1 is delta H2 divided by 2. So which option? So either B can be an answer or D can be an answer. Then how we can relate the Kc1 and Kc2 for the both reaction? So when we write the expression for Kc, for the first equation, we call that equilibrium constant as Kc1 is equals to the product, which is hydrogen raised to power half, iodine raised to power half, divided by hydrogen iodide. And when we write for the second reaction, if we write the expression for Kc, that is the product divided by reactant. So product is hydrogen iodine divided by hydrogen iodide. Now what we do, we will, because we want to make, like we want to compare like Kc1 with Kc2. So to compare the two equations, the number of, like we have will make the right hand side equal. So what I can do, either I can take a root, because here half half and 1 is there. So what I can take a root for both. So if I take under root both sides, or what I can do, I can square the first equation. So it does not make difference. So I will take a root both sides. When we take under root both sides, so Kc2 is equals to, when we simplify this, like under root Kc2 is equals to, when we take a root for this one, it will be hydrogen ion. I will write it here. So when we take a root means power 1 by 2 or half. So this will be half this, half of iodine, and this half square and root will cancel out, so there will be power 1 here. So now the right hand side are equal, so left hand side will also be equal. So we can say that Kc1 is equals to Kc2 raised to power half, or raised to power half means under root. So I can also say Kc1 is equals to under root Kc2. So Kc1 equals to under root Kc2. That's the expression. D is right, like enthalpy change is for the first one is half of the second one, and Kc1 is equals to root of Kc2. Is it clear, this one? This question about the enthalpy. So always try to make the number of the moles right hand side equal, so the left hand side will also be equal. Then next question is question 17, then 28. In question 17, an equilibrium can be established when a solute dissolves into different solvents, like the rate of mixing or transfer of the solute in the two mixtures will be same, then it reaches equilibrium. So they mentioned the equilibrium constant known as the partition coefficient indicates the distribution of a solute between the two solvents. This question is about ammonia dissolving in water and trichloromethane. So ammonia can dissolve in trichloromethane or ammonia can dissolve in water as well. Ammonia is more soluble in water than trichloromethane, means like the amount of ammonia will be greater in water as compared to that of trichloromethane. The density of a trichloromethane is 1.48 where water is 1. So it means trichloromethane is high density. So if trichloromethane is high density, it should be lower than and water should be above. So first thing, when we check the options, the water should be, so this why A is, first thing why A is wrong, because water according to density, then water's density is low and the trichloromethane density is high. So trichloromethane density should be bottom and the water should be there at the top. So A and B are totally wrong because the water position is not correct. Then here's it, either it can be C or it can be D. But as I mentioned, ammonia is more soluble in water as compared to trichloromethane. So high concentration of ammonia will be there in water and low concentration will be there in trichloromethane. That's why option C will be the right answer for this. And in part B, at 25, when ammonia is dissolved in a mixture of a water and trichloromethane, the equilibrium concentration of ammonia in water is 1.02 and in trichloromethane is 0.045. What is the value for equilibrium constant? So equilibrium constant is a product divided by reactant. So when we write the value for Kc or Kp or equilibrium constant, so this is a product for us and this one is a reactant. So it is a product. So concentration of ammonia in aqueous divided by concentration of ammonia in trichloromethane. So trichloromethane, TCM. So concentration of ammonia in aqueous, that's given 1.02 and the concentration of ammonia in trichloromethane is 0.045. So when we divide them, we'll get 22.7, the value for the equilibrium constant. So equilibrium constant, it is always the product divided by the reactant. Next is question 28. In question 28, we have 4 moles of methanoic acid are reacted with 6 moles of ethanol. So we have methanoic acid, which is HCOOH. Ethanol is C2H5OH. Give HCOO C2H5 plus water H4. So 4 moles of, so in the beginning, initial, we were having 4 moles of this and 6 moles of this, and we have 0 and 0 because in the question they don't mention we have a product, so we consider the product is 0 in the beginning. But at equilibrium, we got 3 moles of methyl ethanoate, which is a ester form. So we got 3 moles of this. Now, what is the value for Kc? Kc is the product divided by reactant, but we should know the equilibrium concentration. So we know according to equation, the ratio is 1:1 between methanoic acid and methanoic acid and ethyl methanoate. So ethyl methanoate and methanoic acid, the ratio is 1:1. So if 3 moles are produced, so 3 moles should be there. If ratio is 1:1, if 3 moles are produced, 3 moles should be reacted. But when we write how many are there at equilibrium, we write how many left at equilibrium. So out of 4, 3 are reacted. So how many left at equilibrium? That is 1. Same thing, ratio between ethanol and ethyl methanoate is 1:1. So if 3 moles are produced, so 3 moles should be reacted. So out of 6, if 3 are reacted, so left will be 3. And what about water? The ratio between the ratio between ethyl methanoate and water is 1:1. So same number of moles of water will be produced. Now when we find the value for Kc or Kp, it is a product divided by reactant. So the concentration of a product, that is the ester, ethyl methanoate, water divided by methanoic acid concentration. And because when we divide all of them by volume, so we can take the mole ratio instead of substituting a concentration, so we'll get the same answer, C2H5O. So this is the equilibrium concentration of the ester is 3, equilibrium concentration of water is also 3, equilibrium concentration of methanoic acid is 1, and equilibrium concentration of ethanol is 3. So when we simplify this, we're left with 3. So option C will be the right answer for this. So this is C is the right answer for this one. So these are the doubts related to the exercise, equilibrium constant, Kc and Kp MCQs.